All right, hi class. So today we're going to be looking at our last lesson for chapter 1. So this is lesson 1-10. Make sure you get this in your notes. So we're going to be looking at operations with numbers in scientific notation. And let me zoom in here. So our objectives for today is we're going to apply properties to calculate, or calculations with numbers in scientific notation. So we're going to be using the properties of exponents in calculating scientific notation values. So we're going to be multiplying numbers that are in scientific notation and dividing numbers that are in scientific notation. All right, so let's go ahead and look at this first example here. So we're going to add or subtract numbers in scientific notation. So the mass of the Earth and the mass of the Moon are shown. How much greater is the mass of the Earth than that of the Moon? So we're comparing the Moon with the mass of the Earth, and you can see that the Earth is significantly larger than the Moon, because we can see that here the Moon is 10 to the power of 22 and the Earth is 10 to the power of 24. So one way we could do this is in standard form. You could write this all out. Wynn did that with 1 centrillion. I can't even remember what number that was, but he said it was 303 zeros. So clearly Wynn would probably like to do it this way in standard form. But there is another way that we can do this. We could look at this. We could write the mass using the same power of 10 and then subtract, because we're finding the difference. So what we can do is we can rewrite 5.97 times 10 to the 24. We want to find this to the power of 22, so we can rewrite this as 597 times 10 to the power of 2 times 10 to the power of 22. Okay? Actually, this is a decimal here still, so we can rewrite this as 597 times 10 to the power of 22 minus 7.35, so the Moon, 10 to the power of 22. So they're both the same factor, so we can rewrite this as 597 minus 7.35 times 10 to the power of 22, since the bases are the same, so that a value is the same. So then when we take the difference, we will get 589.65 times 10 to the power of 22. And we can rewrite this back into scientific notation, so we'll move our decimal over 2 places. So that gives us 5.8965 times 10 to the power of 24 kg. And that's about right. All right, so the key here is to change it so our exponents are the same, okay? All right, so you can go ahead and do this one on your own. I'm just going to have you pause the video, and then after you've tried it, then you can follow along. All right, so the values here we have are 10 to the power of 1 and 10 to the power of 7. So then we can have that same exponent. So this will be 22.5. We've changed that 2.25 to 22.5 because that's times 10. And then we are adding the 22.5 and 22.5. And you get, when you add those two together, you get 25 times 10 to the power of 7. So then when we convert this back into scientific notation, that's 2.5 times 10 to the power of 8. Okay? All right, so we're going to multiply numbers using scientific notation. So the Confederation Bridge connects New Brunswick to Prince Edward Island. The main part of the bridge rests on piers that form 43 segments. So they're on these piers that form 43 segments. What is the approximate length of the main part of the bridge? Express your answer in scientific notation. So we know that the distance between each pier here for each segment is about 8.2 times 10 to the power of 2 feet. And there are 43 of these. So we can take that and multiply that times 43. Okay? So we can change this value into scientific notation. So we can have 8.2 times 10 to the power of 1 times 4.3 times 10 to the power of 1. So we've expressed both of these values in scientific notation. Now we can rewrite this. We can multiply these A's values together. So we will have 8.2 times 4.3 times, oh, this was 10 to the power of 2, I'm sorry. 10 to the power of 2 times 10 to the power of 1. And we know we will just add those exponents together. So when we multiply 8.2 times 4.3, you will get 35.26 times, you know what, for scientific notation we use the x, 10 to the power of 3, because we're adding 2 and 1 together. And then after we want to convert this back, or we want to convert this into scientific notation, so we need to move our decimal one place over. So our answer will be 3.526 times 10 to the power of 4. Okay, so that is our answer. So here's a skills-based question, no application involved. I want us to go ahead and multiply these two scientific numbers, notation numbers together. Okay, so a way that we can do that is we can rewrite 3.1 times 1.2. Multiply those together, and we can multiply 10 to the power of 6 times 10 to the power of negative 2. So 3.1 times 1.2, 3.1 times 1.2 gives us 2 and 6 and 1 and 3. So it is 3.72. 3.72 times 10 to the power of 6 plus a negative 2 will give us to the power of 4. So that is how we can multiply those. So multiplying numbers that are in scientific notation form is much easier because we only had to multiply these A's values together. See how much easier that was as opposed to converting these to standard form and then multiplying that. That would have so many zeros, it would be much longer. So this is a strategy that we can use that is much faster. All right, a queen ant lays 1.83 times 10 to the power of 6 eggs over a period of 30 days. Assuming she lays the same number of eggs each day, about how many eggs does she lay in one day? Express your answer in scientific notation. So first write 30 in scientific notation. So we want to write 30 into scientific notation. And to find out how much she is laying in one day, we will take the number of eggs that she is laying. So 1.83 times 10 to the power of 6 divided by 3.0 times 10 to the power of 1. So that's the same as 1.83 times 10 to the power of 6 over 3 times 10 to the power of 1. Okay? So we can rewrite this as 1.83 divided by 3 gives us 0.61. So it will be 0.61 times 10 to the power of 6 minus 1. When we're dividing, we subtract the exponents, so it will be minus 1. So it is 0.61 times 10 to the power of 5. But we need to change this into scientific notation because our A value needs to be moved, or needs to be between 1 and 10. So it will be 6.1 times 10 to the power of 4. in a way that we can think about, does this number get bigger or smaller? We are moving this to the right, so this number is getting, this number will be smaller, right? So we change it to 4, okay? All right, I'd like you to go ahead and try this one on your own. All right, now that you've done that, what we're going to do is you will take 2.6 times 10 to the power of 18 divided by 1 times 10 to the power of 14. So that is 2.6. 2.6 divided by 1 is 2.6 times 10 to the power of 18 minus 14. So you should get 2.6 times 10 to the power of 4 will be your answer. That's how many participants will be at the soccer stadium. All right, let me know if you have any questions. That's it. We are done with all of our lessons for this chapter, so we will be having a test coming up. Please write down any questions that you may have. Great job.